Alright, in this problem, the second one, tells us to find all values of theta in the interval of 0 less than or equal to theta less than or equal to 2 pi, for which 2 sine theta minus 1 equals 3 over sine theta. First thing I like to do is always draw a line down my equal sign, which separates the sides left and right. To get rid of this fraction, I'm going to multiply both sides by sine of theta. Notice how this side I put it as a fraction because you have a fraction, this side does not have one, so I don't need it. Here I can simplify sine of theta equals 1, so those cancel. And then over here I'm going to distribute. Class, what's sine times 2 sine?
2 sine squared.
And sine times negative 1? Negative sine theta. This side, these cancel and left with a 3. Can I factor this? No. Remember in quadratics, I need to set this equal to 0, so I'm going to subtract 3. Squeeze that in right there. 2 sine squared theta minus sine theta minus 3 equals 0. If you want to rewrite the problem without trig functions, it's fine just to help you kind of visualize it. Some of you do not need the scaffold. 2x squared minus x minus 3 equals 0. From here we can just factor. A times c is negative 6. My b value is negative 1. Two numbers that multiply to be negative 6. 2 and 3, but they have to add to be negative 1, so one of those has to be negative. Empty my box. So here I have my 2x, and over here I have my negative 3x. My first term I'm going to put in the top left, 2x squared. Bottom right, negative 3. And then from here I'm just going to take out my greatest common factor. Greatest common factor in this direction is going to be a 2x. In this direction is just going to be an x. Greatest common factor in this direction is just a negative 3. And you can also think of it as x times something equals negative 3x. That would be a negative 3. And over here that'll be a plus 2. So when I write this now, I'm going to have 2x minus 3, but instead of having the x, now I can put my sign back in there. Oh, you are right. Good job, Tom. Is it plus 1?
Yeah. Yes.
And then in this direction it'll be what?
It'll be sine.
So basically we just factored. Next I'm going to apply the zero product rule, where I'm going to split them and set them equal to 0. 2 times sine x minus 3 equals 0. And sine of x plus 1 equals 0. Here I'm going to add 3 to both sides. 2 sine x equals 3. And then I'm going to divide it by 2 on both sides. Sine of x equals 3/2. If I take the inverse, I get the inverse of sine of 3/2 equals x. So the question is, on my unit circle, is there a place where sine is 3 over 2? There's radical 3 over 2, but not 3 over 2. The second thing you can think about is using your calculator. If you put into your calculator, you'll see something. But to give yourself a quick idea, here's the graph of sine. And they're asking for 1.5. Class, does the graph ever hit 1.5? So the answer here is no solution. On this side, I'm going to subtract 1. Sine of x equals -1. Inverse of -1 equals x. I'm looking for it in radians. 2 locations where sine is equal to -1. Using your unit circle, sine there is -1. It's only one location. So the only answer in this whole problem is x equals 3 pi over 2. So, recognize if a problem is linear or quadratic. If it's quadratic, set it equal to 0. See if you can factor it. Think about a problem. You can even put that into your calculator and recognize that you'll get an undefined or no solution.